Hi, I'm Tim Fox, and I'm here to talk to you today about large-scale deep learning with BigDL. Little about me. I'm a data engineering and data science practitioner and a partner and principal at Elephant Scale. At Elephant Scale, we do training in big data, AI, deep learning, and machine learning. And I'm an author of Data Science in Python on LinkedIn Learning and an open source contributor to projects such as BigDL. Okay, I'm going to start out with a quick roundup of AI, machine learning, and deep learning. Now, AI is simply a broad category which talks about machines being able to carry out smart tasks. And that can mean a lot of different things. One subset of AI is machine learning, or ML. It is a type of machine learning, it's a type of AI that allows software to learn from data without being explicitly programmed. And deep learning is a subset of machine learning in which we use neural networks to solve some hard problems. Okay, some applications for deep learning are applications like self-driving cars, which uses machine learning for image recognition in order to determine the edge of the road signs, cars in front, etc. Facial recognition is another common application. Facebook images and is able to manually tag from a data set and then automatically detect faces in uploaded photos. So a bit of history of deep learning. So neural networks have been around for some time, but there's some early attempts there that didn't quite succeed because of a lot of reasons. Compute power being insufficient, training data sets being insufficiently sized, and the lack of the ability to parallelize. But now we have several things that have made our efforts more successful, one of which is big data. So now we have the ability to have lots of data to train our models. The big data ecosystem, we have platforms like Hadoop, Spark, NoSQL, etc. as open source, and they are able to help us to have an ecosystem that is friendly to big data. And then we have big compute. So cloud platforms like AWS, GCP, Microsoft Azure, etc. give us the ability to have very affordable scale for being able to scale up on our compute. So you can see there some of the costs that are associated with that. It also gives us a flexibility of having dynamic workloads. There's a number of different projects around the AI software ecosystem, and many of you are probably familiar with libraries in languages like Python and R, which give us the ability to do general machine learning. Scikit-learn and many of the CRAN libraries in R give us that. We can also do distributed machine learning using H2O and Spark MLlib for that. Now, on the deep learning side of things, we generally have specialized frameworks for that. And many of you might be familiar with deep learning frameworks like TensorFlow, Theano, Caffe, etc. And there are some efforts now on doing distributed deep learning, and one of which I'm going to highlight today is BigDL. In the past, a lot of machine learning was done on a single computer with a lot of memory. And in fact, a lot of machine learning libraries and deep learning libraries are basically single node based. They do not easily allow us to extend our workload into a cluster. However, big data tools we have today like Hadoop, Spark, etc. allow us to do machine learning algorithms at scale distributed across the cluster. Now, you're probably familiar with a number of the modern deep learning frameworks that we have, TensorFlow, Keras, Theano, etc. So this is part of the modern ecosystem we have in deep learning. Now, for scalable machine learning on clusters, you may be familiar with Spark ML, which is designed to give us affordable, that is open source, scale with traditional machine learning. However, it does not cover deep learning so much. Now, BigDL brings deep learning to Spark, and we're going to be talking about that in the rest of this series that we have. TensorFlow is a Python and C++ based library, which is a deep learning library. It runs on CPU and GPU, etc. And there are many other similar deep learning libraries as well, Torch, Theano, Caffe that we mentioned as well. Now, on the cloud, we have a lot of both pre-trained models as well as API managed based machine learning, such as Google Cloud ML, Azure ML Studio, Amazon Machine Learning, etc. Okay, so let's get to BigDL. So what is BigDL? Well, it is a distributed deep learning library built on top of Apache Spark. And it's designed to give us feature parity with popular deep learning frameworks like Caffe, Torch, TensorFlow, etc. And it also gives us high performance, which is powered by the Intel MKL, multi-threaded programming, etc. And it can, most importantly, scale to huge data sets. And it builds on top of Apache Spark and Apache Hadoop and other frameworks in order to achieve that kind of massive scale on huge data sets. And it is open source. The version 0.3 was just released. BigDL runs as a Spark application, similar to other Spark applications like Spark SQL, Spark MLlib, and Spark GraphX, and other things. It supports Scala and Python. It is natively written in Scala. It uses Spark's other features like in-memory compute on the Tachyon and Luxio, integrated with Spark ML and streaming, and allows us to do easy development with Jupyter Notebook. Now, comparing BigDL to other deep learning frameworks like TensorFlow, Theano, Caffe, and others, BigDL gives us a Scala engine with a Python front end. Now, TensorFlow gives us a C++ engine with a Python front end. Acceleration with BigDL is primarily CPU based, which fits in well with our native Hadoop and Spark clusters. TensorFlow relies on GPU processing for maximum performance. BigDL runs natively on Spark and Hadoop, whereas most other frameworks do not run natively. They can, at best, access Hadoop data as a client only. And that's true of TensorFlow as well. BigDL relies on Apache Spark for massive scale. Other deep learning frameworks like TensorFlow do not support massive distribution out of the box, unfortunately. BigDL runs TensorFlow models. And so, in summary, BigDL is going to be excellent for distributing our deep learning models to massive scale on big data. Now, BigDL helps us in balancing our needs between big compute, giving us fast linear algebra, the Intel MKL library, and big data, which gives I/O parallelization to run on large clusters with many CPUs. It allows us to run on Apache Spark and works with the Hadoop ecosystem via Spark. Now, if you're not familiar, Hadoop is the big data platform for on-premise deployments. And the fact that BigDL is part of that ecosystem is a huge advantage in terms of massive scalability on big data. It also plays nicely with other frameworks. For example, TensorFlow and Caffe models are available to use at scale in BigDL, and we can train new models based on existing TensorFlow and Caffe models. Now, what about GPU and CPU? Now, GPUs, of course, have created a lot of excitement in the deep learning community. And in the past, CPU has not been vectorized for parallel compute, which meant that in the past, GPUs were much faster for deep learning. However, modern Intel Xeon CPUs have vectorized linear algebra that, when properly optimized, can approximate the speed of GPUs and allow us to do faster I/O performance for big data. Now, the Intel MKL, or math kernel library, gives us highly optimized, multi-threaded, and vectorized math functions that will maximize the performance on our processor family. It uses industry standard C and Fortran APIs for compatibility, and it allows us to distribute optimized code for our processor. And you can see here that deep learning performance, when properly optimized for the Intel math kernel library, can be dramatically faster than an unoptimized code and approach the speed of GPUs. So CPUs actually have a lot of advantages for big data. For one thing, our existing big data infrastructure mostly runs on CPU-based instances. So we can leverage all the CPU-based instances that we have. And since BigDL can run on those effectively, that gives us a really great advantage for that. It turns out that although ML and deep learning can be some of the most exciting and interesting parts of our data pipeline, actually speaking in terms of code, it tends to be a relatively small piece of a larger puzzle. We generally have a number of different pieces of the puzzle, for example, like configuration, data collection, feature extraction, etc., and infrastructure that we need. These are going to be running in the big data ecosystem on Hadoop and Spark, and being able to run on a scalable platform like Spark helps us simplify the complexity, avoiding having to have separate clusters, separate nodes, etc., to do our deep learning workloads. It basically fills in the gap. Big data up to heretofore didn't really have much of a deep learning component that we could use. It allows, though, us to use the architectural principles that we've learned in big data, sending compute to data rather than the other way around, using data locality of Hadoop Distributed File System, HDFS, and other similar file systems as well, and utilizing cluster managers like Yarn and Mesos. Some of the use cases we can use for BigDL are things like fraud detection, sentiment analysis, and many others. And we have a GitHub here that I show here that you can see a number of different use cases we've outlined. Okay. So I'm going to show you here how to run BigDL. So we have offered several different options for getting you started immediately in developing your BigDL apps. One of which is a Docker container, which I'm going to demonstrate in this video. We also additionally have a VM Sandbox that will be better for some users, and I'll explain the situations where that can be true as well. And also we have a deployable cloud-ready Amazon AMI ready for deployment in the cloud as well. So we have a lot of different options, and it's our goal that you should be able to immediately get going with BigDL. Let's talk about how to start BigDL from using the Docker container. Now, Docker is a great way to go if we have a Mac, a Linux machine, or if we have a Windows box which is running Windows 10 Professional with Hyper-V installed. So if that fits, then we should proceed ahead with Docker for the Sandbox. If not, we may want to consider using the Elephant Scale Sandbox VM, which we can download for VMware or VirtualBox, and we'll talk about that in a minute. So proceeding ahead with Docker, let's go and first ensure that we have Docker downloaded and installed on our local system. Now, I'm running a Mac, which means I'm going to go to the docker.com site. I'm going to go click on Mac, and I'm going to go ahead and download that from the Docker store and click on Get Docker. Okay, so you see now that Docker is downloading from my platform, and I'm going to go ahead and click on this. This may look a little bit different on Windows or Linux, but nonetheless, we should follow the instructions for performing the installing the Docker application here like this. All right, great. So, now that I've installed Docker, I'm going to go ahead and check that Docker is running. Here I can go and see, indeed, Docker is running on my platform. So I do have it running. That also will enable the Docker command to come from my command line, which is what I'm going to do. The next step is I'm going to go ahead and I'm going to pull the latest image of the Elephant Scale BigDL Sandbox from Docker Hub. Now we should have downloaded Docker for our platform, and that will allow us to do containers. So we can test this by just checking to see if Docker is currently set up the command line, and it appears that it is. So that's excellent. Now, in order to use this, we will have to have an account with Docker Hub. So if you haven't already set one up, go ahead and do that. As a matter of fact, actually, I'll illustrate that we will need to. So here is Docker Hub, and you can just go ahead and sign in there. So now, to log in to your account, you'll need to type in Docker login if you haven't done this already. Probably many of you have. So then it'll ask us what we want our Docker ID to be. In my case, I, of course, already have it there. And then type in your password. And notice it says login succeeded. And so that's going to be all we need then for logging to Docker Hub. And we'll need to do that because we'll need to grab the Elephant Scale Sandbox Docker image from there. Okay, next step is we're going to go to www.github.com/Intel Analytics. And this will give us all of the repositories here for BigDL, including our BigDL trainings repository here. So that's github.com/Intel Analytics, BigDL trainings. And what I'm going to do is I'm going to clone this in on my system. So I'll say git clone. So now that should give me a directory here called BigDL trainings. Okay, now let's go there, and under here there's a directory called Elephant Scale, and notice here we have our directories. We have Docker. So if I say Docker, this is going to have the Docker file and the image there. Now that's going to be useful if you want to modify in any way the Docker image that we have here. We don't need to do that because we can just pull it directly off of Docker Hub, and that will actually be faster. But nonetheless, that is there. You can use that for your own purposes. Now there's a couple scripts here. One is run BigDL native. What that will do is that will run BigDL locally on your own box. However, and actually we're going to demonstrate how to do that with running inside the Sandbox. We'll write for this running locally on our laptop, as long as our laptop or other box supports that. We're going to run with run BigDL Docker, which is what I'm going to demonstrate here. What I'm going to do is I'm going to say run BigDL Docker, but to do that, I'm going to first need to do a Docker pull on Elephant Scale /BigDL-Sandbox. That is the name of our Docker image. So again, that's elephant scale / BigDL sandbox. Now, if you haven't already run this, this will take a while depending on your internet speed to download. So go ahead and get the latest of that. Now, it will again take some time, but in my case, actually, since I already had everything up to date, it now has pulled that down, and we have the elephant scale BigDL sandbox loaded. And as a matter of fact, I can check that by saying Docker images. Okay, notice we have it here, BigDL sandbox. So we got the latest, and it's all good to go, and here's the image. Okay, so now let me going to actually run that using the script. So I have run BigDL docker.sh, and I'm going to run the elephant scale / BigDL-sandbox. So now what that will do is that will take the image. I could have also actually put the image ID here if I wanted to, but the name is fine. So now if I go ahead and run this, what this is going to do is this is going to run Docker along with that container that I want to run, and that's going to have BigDL, Spark, Python, and everything else I need to run. So notice it's going to run. So it's going to run a script, and what it's going to do is it's going to immediately start up Jupyter Notebook for me. Now, if I don't want to run Jupyter, if I just want to run, some other code that I might have, I can actually Control-C out of this and then do that. But for me, Jupyter is what I want to run. So let me go ahead and get this started. So let me go ahead to here, and so to my browser, and I'm going to take the link here, localhost with my token, and this is going to put me into my Jupyter Notebook. Now I'll go under the work directory here, and I'll go to notebooks. And if I go here, then you'll see that I have several notebooks, all of which are for future examples. One of which I want to pay your attention to today, though, is the testing 123 notebook. So, okay, so here's the testing 123 notebook. If I go through and I run the cells here one by one, you can go ahead and see the results. So notice here when I say SC, it prints out the Spark context. Now that proves that Spark is currently running and operating in my Docker container. And in fact, if I call the newer API for Spark, you're probably familiar with that if you know about Spark. Spark session object, again, this is saying that I have my Spark running. This is going to be a Spark data frame that it's going to set up within this within my Spark framework. So you can see that I have that here. Very good. All right, so for this level, it says BigDL imports. So I'm going to go ahead and run this. Now, this is going to prove that BigDL itself is set up. And in fact, the imports seem to be working good. I'm going to do a hello world with BigDL. You can see that we have the BigDL libraries here. And so what I'm going to do is run this. This should not work unless BigDL is properly set up. And you notice here, it created, said hello BigDL world and created a linear layer. So a very simple hello world DL layer. And we see that worked as well. In this frame, we're testing NumPy and Pandas. Make sure that we have kind of our basic data science stack set up here. And sure enough, we do. And finally, we're going to try a few other Python packages. In this case, NLTK. So NLTK is working, as you can see. Also, we're going to be doing visualizations, which we'll need. So we're going to test matplotlib here. We do see you. And we have Seaborn. So Seaborn, I'm going to run that. All right, and see Seaborn is prettier than matplotlib, so we can see that there. In the next section of this video, I'll be going on to show you the same material, but inside of the Sandbox, the elephant scale Sandbox VM. Okay, so now we're going to discuss how to run the elephant scale Sandbox VM. Now, we've already talked about Docker, but for some, Docker may not be the most appropriate option because those running on some platforms, for example, on the Windows platform, may find that their version of Windows does not support Docker. Specifically, users who are using any version, any home version of Windows or anything less than professional probably do not have the proper VM support libraries to run Docker. And also, those users running versions of Windows that are older than Windows 10, such as Windows 8 and Windows 7, also may have some issues in the same. However, those Windows users should be able to use the elephant scale Sandbox VM which is going to run on a traditional VM platform, which is supported on older versions of Windows. Also, users who have other operating systems and other platforms may just simply prefer using a VM environment versus a container environment in Docker. So that option is going to be available. So let me demonstrate how that works. Okay, so we're going to go to www.elephantscale.com/sandbox. Now, when we go to Sandbox, you'll notice that we have a link to the VMDK file. So it will take some time to download this. So I'm going to go ahead and start downloading it right now. Okay. And now, while that's downloading, we're going to also need a application to run the VM. Now, there's two choices of that. One of which is VMware Player, and the other is Oracle's VirtualBox. Now, VirtualBox is completely open source and free, so I'm going to show downloading that. However, VMware Player will just work as fine as well. Okay, so let me open up a new tab, and I'm going to go to VirtualBox. And we're going to download this for our platform, which in my case is going to be an OS 10 operating system because I have a Mac. But for those who are running Windows, we'll click on the proper platform. Okay, so you can see that that is currently in the process of downloading. Okay, so VirtualBox is now downloaded. The installation will depend on your platform. And I know a lot of these users are going to be using VirtualBox, going to be Windows users. But the installation, we can just go ahead and open that. And notice here that it's going to start that up and install it in a way that's appropriate for your OS. For Windows users, that'll probably be using the MSI or Microsoft installer. Here on Mac, I'm going to load the DMG and then install that. My OVA file is downloaded, so with VirtualBox installed, I should be able to load the virtual machine and get the Sandbox set up. So let me do that. Okay, so I'm going to go import appliance. Go to my downloads and get the OVA file I just downloaded. And I will click on import. And now it's imported my virtual machine. So let me look at this. In my case, I'm going to change the base memory because on this particular machine, I don't have that much memory. Of course, if you do, then that's certainly give it as much memory as you feel comfortable with. But I'm going to look at the settings here, and let's dial down the system memory down to something that'll run a little bit better for me. Okay, now I'm going to go ahead and start this up. Okay, the password is, according to that, you can see this on the website, is BigData123. We have our elephant scale sandbox started. I'm going to open up a shell window. And one thing I'm going to do is I'm going to go ahead and install Apache Spark. There's a Spark 2.2 already in the files directory here on the sandbox. So that's good. So also I'm going to just move this to just plain old Spark. Good. So now I should have a directory here called Spark. What I'm going to do with the Sandbox is I'm now going to go ahead and clone the repo for this for BigDL, our tutorials. So I'm going to open up a window here, and we will go to github.com/Intel Analytics. And we want a BigDL training. So let's just get that here. So if I go back here and I say git clone, okay, so notice I now have the BigDL trainings here, and it's under elephant scale. Alright, so now I have a run BigDL native script here, and we can also run BigDL Docker if we have Docker set up here on the VM. I'm going to look at the run BigDL native, and notice I need the BigDL home set properly to my location for BigDL, and also my location for Spark. So it looks like I already have BigDL properly set up, so I can go ahead and run that. So okay, so now that I have that, let's do a run BigDL native. Okay, so now notice that it started Jupyter Notebook for us, just like it did on Docker. So let me just go ahead and copy this here. Great. And we'll go to my notebooks. And notice the testing 1, 2, 3 is right here. As before, if all this looks good in testing 1, 2, 3, then we can declare victory and move on. All right. Thank you very much for spending the time with me to set both the Sandbox and the Docker container up. And please tune in for my next video in this series. Thanks again.